Your Kate's gone. Right. Bye, Kate. So Fletcher, it's you, me, Hannah, and Jasmine. Cool. Right. So hopefully this is recording. So let me know how it goes. So page 57, question 3. Oh God. Yeah. Right. Find the value of theta in terms of pi if that is that. Okay. So this is not an easy question. It looks real ugly. So tan of theta equals tan of pi on 3 minus tan of pi on 6 all over 1 plus tan of pi on 3 over, times pi tan of pi on 6. Hannah, Jasmine, are you there?
Yeah.
Okay, perfect. Right. Now what I want to do is I just want us to look at this part here. There's a minus here and a plus here, right? And so this reminds me of this formula, the tan compound angle, because it said tan A plus or minus tan B over tan minus plus 1 minus plus tan A tan B. Yeah?
Yeah.
And so for me, if there's a minus on top, then there's a minus in the brackets. Okay? And so tan. And for me, A is the first one, so that's pi on 3. And B is the second one, so that's pi on 6. So this whole thing, tan theta is equal to tan pi on 3 minus pi on 6. And what is pi on 3 minus pi on 6? I'll multiply them both by 2. So they both have the same denominator. 2 pi on 6, take away pi on 6 is just pi on 6. So theta is pi on 6. Or a multiple. Or 2 pi plus pi on 6, or any multiple pi plus pi on 6. But that doesn't matter so much.
Okay.
Does that make sense?
Yeah. I couldn't figure out how to do.
Yeah. No, but Fletcher, yeah, you're right. Like the weird thing is, it looks crazy, but the thing is, I know it's this formula here.
Yeah, yeah.
And the moments that, yeah. So I'm not live streaming, so it's okay. What was that, Fletcher?
I just couldn't figure out how to do the pi minus 3, pi minus 6. Or pi over 3 minus pi over 6.
Yeah, well, pi over 3 minus pi over 6, that's probably the tricky part, but you just deal with it like fractions.
Yeah. Yep.
Okay. Girls, does someone have a question?
I've just hit a watch.
Okay, cool. And Jasmine, what about you?
On page 42, question 7.
Yeah, I can do that. Fletcher, is that cool?
Yeah, yeah.
Page 42, question 7. Oh yeah, let's go. Page 42, question 7. Okay, the question is... Okay, yep, okay. Let's try that. I'm going to try draw a picture of that. I do apologize if it turns out horrible. Okay, there's a straight line here. And because I care, I'm going to do it actually neat. Oh, dear Lord. Oh, my Lord. Okay, here we go. All right, so let's get rid of the ruler. So we're going to draw a sine curve. Jasmine, are you okay with that sine curve?
Yeah.
And I'm going to label A and B.
Mm-hmm.
Yeah?
Yeah. Yeah.
Find the formula connecting. Oh, Who's the one that's got their not got headphones in? Okay, never mind. It works now. Okay, cool. Sometimes I come through and I hear myself, and it's a bit wild. Okay. We know that the height of this, both of them, is the same, right?
Yeah.
So we know that sine of A equals sine of B. That B looks really ugly. Okay, that's really cool. You know, that's an interesting way to connect it. That could be my answer. But I think we can find a better way. Well, do you notice that this is at pi?
Mm-hmm.
Hello?
Yeah. Yeah.
I know that if I go, so this distance here is A, right? And so what's this distance here?
Pi.
Yeah, and so what's this distance in the middle in here then?
A minus pi.
Yeah, A minus pi. Okay, similarly, what's this distance here?
2 pi.
Yeah, that's 2 pi. And what's this distance here?
B.
So what's this distance here?
2 pi minus B.
Okay, are they the same?
Yes.
They are. So what I can then do is I can make the equation. A minus pi is equal to 2 pi minus B. Right, can you write one in terms of the other now?
Yes.
I'll add pi to both sides. A is equal to 3 pi minus B.
Okay.
Does that work? And what does the answers have? Question 7. Page what?
Page 42.
Page 42. Yep. And, you know, their answer is A plus B is equal to 3 pi, but it doesn't bother me, right? We could do whatever, however you want to connect that.
Okay.
Does that make sense?
Yeah, it does.
Okay. Cool. Brock, did you have a question?
1 second. Okay. Yes. I'm not too good on the new stuff that we've just been told to do. For some weird reason, I get page 68. I get the second page, but not the first page.
Page 68, you get the second page, but not the first page.
Yeah.
Yes, the second page will be nicer.
I get a couple right, but I don't know how. Like, it's random.
Okay, second page makes sense. Okay, so the second page makes sense because the second page is sort of like finding general solutions, and you just leave it as general solutions. Whereas the first case is not just finding general solutions, but finding particular solutions, right?
Yeah.
Can we do maybe 1A and compare our answer to, say, 2B and see how similar they are and the kinds of ways we do it?
All right.
So page 68, question 1A. Everyone else, is that okay?
Yep.
Cool.
Yep.
Okay. So this one is solve for x. Okay, solve for x, and then 2 cos x equals -1. And then they said this weird thing here. And that's the domain for where your solutions are. Okay, so that's where your answers are going to be. So let's try solve it, okay? So what I'm going to do first is I'm going to go cos of x, 2 cos of x is equal to -1. I'm going to divide by 2. That's okay, right?
Yep.
And then I've got cos of x is equal to -half. Now, cos of x is equal to a -half. And now if you go into your calculator, cos of x, cos inverse of -half, your calculator shall spit out an answer. What's it give you?
What? 120?
Your calculator is set in radians. It is in degrees. Change it to radians.
I don't know if I've done it right. Yep, okay, it's in radians.
Yeah, so the answer is?
1 second. Okay, 2.09.
Yep, the answer is 2.09. Yeah? And what I'm going to say is just divide your answer by pi and tell me what you get.
2/3.
Is 2/3, right? And so as an exact value, my thing is going to be 2/3 of pi. Okay, but I'm just really, do I want to focus on this part? I sort of ignored this part because I was like, I can't show you, but anyway, have a look. So cosine of x is equal to -1/2. So cosine is adjacent over hypotenuse, right?
Yeah.
And so the adjacent is going to be at -1, and the hypotenuse is 2. So it's -1, and hypotenuse is 2, and I'm trying to find this angle here. All right? What is my angle? Well, if I look at this, well, I know a 1, 2 root 3 triangle will tell me that this is pi on 3. And so what's left over is if I have pi take away pi on 3, that's the same as 2/3 pi, right?
Yeah.
And so I could have got this angle without doing cos inverse of -half, but I did because I like to, and I know it will work. But this part I've sort of skipped over because I've not had a chance to see us in class. So, but we may have done this a bit. We will do this a bit later in complex numbers, so I won't stress about it right now. Okay.
Cool.
But do you appreciate that this alpha is 2/3 pi?
Yes.
Okay, and so then you're like, okay, so this equals, and our cosine general formula was 2
Yeah.
n pi plus or minus our alpha. And so what was our theta in this question?
I'm not sure.
Our theta was just x, this
Okay.
one here. And so it's 2n pi plus or minus, and what's our alpha?
2/3 pi.
And then you're like, okay, Mr. Dharma, this is wild. What else do we need to know? Well, I'm going to say, well, this is our solution. This is our general solution. But I'm going to draw a rough curve, a rough cosine curve. Because I'm going to draw a cosine curve from 0 to 2 pi, because that's what I want to look at the answers for, right?
Yeah.
And I'm going to draw a line that goes through at -half. And if this is 2/3 pi, how many other solutions am I going to get in 2 pi? How many
2.
other times does the black line hit the blue line?
Oh, sorry. One more time.
Yeah, and it's this one here, right? And so if we have this solution as 2/3 pi, right? Crumbs. If we have this solution as 2/3 pi, let's try to figure out what this one is. Okay, and what we'll do is we'll just plug in, let's plug in n equals 1, right? Into here. Is that okay?
Yes.
So if I plug in n equals 1, I have 2 times 1 pi minus 2/3 pi, and then I have 2 times pi plus 2/3 pi. Now, before I do anything, this is bigger than 2 pi, isn't it?
Yes.
So I'm just not gonna use it. But then I'll look at this one here. 2/3 pi being taken off 2 pi. So 2 pi is another way of saying 6 pi on 3. Take away 2 pi on 3. How much is that?
That's 4 pi on 3.
4 pi on 3. And that is this point here.
Okay.
Cool. And so what are my solutions for this? It's 2/3 pi and 4/3 pi. And that's it. And because I know it's between 0 and 2 pi, all I need to do is go, okay, I've got my answer, and this distance here is the same as this distance here. So I got my answer and then go 2 pi minus my answer, and I get my other answer. And it's all good.
Right.
But if my question, instead of going between 0 and 2 pi, had gone from 0 to 4 pi, how many solutions would I get now?
4.
Yeah, I'd get 4 solutions, because I'd have another 2 solutions there and there. But this one is pi after that, and this one is pi after that. And so I'd just have 4 solutions that I have to talk about.
Okay.
And so my 4 solutions, what would they be? They'd be 2 pi on 3, 4 pi on 3, and then I'm going to add another 2 pi to this. So 2 pi plus 2 pi on 3, and I'm going to add another 2 pi to this, 2 pi plus 4 pi on 3. Boom, done. Those are my 4 solutions. You could simplify them if you want, but do I care? No.
Cool.
All right, so that's how you do exercise N, right? That's how you do question 1.
Right.
But then question 2 is a little easier because you stop just here.
Yeah.
Does that make sense?
Yes.
Okay. Do you want me to do one of them?
I think the fact that my calculator was in degrees was a lot of my trouble.
Oh, God. Seriously? All right. Cool. Brooke, do you want me to do another one, or do you want me to let someone else ask a question?
Maybe someone else can ask a question.
Okay. Fletcher, Jasmine?
Yeah, I've got a question.
Yeah, let's go.
Page 59.
Question who?
2A.
Page 59, question 2A.
Yep.
Oh, this feels very familiar. Here we go. Cot A minus cosec 2A equals cot 2A. Okay. So, do you know what I'm going to do? Because this is, I'm going to give myself some lines because otherwise I'm really bad at drawing. Oh, these lines are super big. Okay. Let's see. Yeah, okay, I'll do that next time. Okay. Cot. Wow. So Fletcher, which side shall we start?
Left-hand side.
Okay, we'll start with the left-hand side. What shall I do?
Would you change cot to the cosine over sine?
Would I change cot to be cosine over sine? Yeah, I could. Shall we do that? Yeah. I'm gonna get. I thought this would be actually helpful, but I don't think it's helpful because I'm about to not draw on lines. Right. Cosine A over sine A. Yeah. And then what am I going to do with this one?
Make it 1 over sine
1 over sine 2A.
2a. 2a. Yep.
Yeah. And then what?
Make them both into the same fraction
How?
by multiplying the cosine a by sine 2a and
Do I want to do that though?
Not sure.
Okay. Before I do, look at this double angle. Can I do something interesting with it?
Or you can make it the 2 sine a cosine a.
Yeah. Let's do that. Minus 2 sine A cosine A. Now what can I do? How do I make the left-hand side the same as the right-hand side? The left fraction have the same denominator as the right fraction.
Multiply it by 2 cosine a.
Yeah, so multiply by 2 cosine A times by 2 cosine A. And so then we'll have 2 cosine squared A over 2 sine A cosine A minus 1 over 2 sine A cosine A. Now what can I do?
Same fraction.
Yeah. 2 cos squared A minus 1 over 2 sine A cos A. Now what?
You can make the top into cos 2a.
Okay, top is cos 2A. What can I do to the bottom?
Make it into sine 2a.
Yep. What can I now do?
And then that's cot 2a.
Which is equal to the right-hand side, which is my answer. Yeah?
Yep. I was writing it down, sorry.
That's okay. Brooke? Jasmine?
I've just got a question. When are the live streams this week?
Oh, I don't have live streams this week.
Good. Okay.
Pardon? Did you say good?
No.
Wow. After all the effort I put in,
So,
were they painful to watch, were they?
no, they were good. It was just like, oh no, my brain can't handle much more.
No, I just wanted to do 3 live streams to cover all of the important things in trigonometry. Yeah, I don't think I need any more live streams on trigonometry. So, yeah. I don't know what's going on. Like, can you see me?
No, I can still see the whiteboard.
I can see you on your phone though.
Oh, you can see me on my phone?
Yep. And you left.
Oh, good. No, I didn't mean to leave, but I'm just like playing around, seeing what works and what doesn't work. Right. Cool. My hair is a mess. Like, this is what happens when you don't get a haircut, and it's just a tragedy. All right. So, next question. What's up? Anyone?
Flip through and see if I've circled anything.
Mm-hmm. Yeah. Because the thing is, I think we're going to have this lockdown for a little while longer. And because of that, I think it's really important that we find something that works. And I'm really trying to figure out what works to help you guys. And I'm not sure I want to, I think from next week, I think I'm going to decide to live stream twice a week. Because I think live streaming every day is a lot more stress than we need. So I might live stream like Tuesdays, Thursdays. And then see how that goes. But, I really want to know from you guys what will work as well. Like, I love doing this kind of thing, but I don't know how to organize this kind of thing. Like, as in, it's easier if you say, hey, sir, are you available? And then I'll be available, rather than me say, hey, I'm available. Because look at what happened in our Google Meet this morning. Like, it was cool to have, like, all of us there, but that wasn't as productive as this is, right?
Yeah.
Yeah, so, whether we have rosters of, hey, can we Google meet you on Monday? Can we Google meet you on Tuesday? Can we Google meet you on Wednesday? Kind of thing. I don't know what will be more beneficial.
Yeah.
But I want to do more of this. So yeah. Anyone with a question, Jasmine?
I lost a piece of paper that I had all the questions I need help with.
Well, it kind of gone too far. It's probably still at home. So. Fletcher, Brock?
Yeah, I've got one. Another
Yeah,
one.
let's go. That's all right. Have as many as you need.
Page 55, question 3A and B. I just confused. There's like
Page
two
55, 3A and B. Yeah, I haven't asked you to do these questions, but you want to do these questions.
Oh, no, I didn't know you hadn't asked.
Well, I hadn't. Yeah, so...
No, we can just leave them.
Yeah, I can do them. Just I don't know if you need them. But let's do them. I'll do 3A, and then you can realize that I didn't want you to do them. Page 55, 3A. I don't think I've asked you to do them. Go check the book thing.
No, you haven't.
Yeah, because I know what I'm doing. Right, I never want you to do weird things like this. Eliminate this, and then in each case, form equations in x and y. All right, simple. X equals 5 cos squared. Cos theta. Y equals 5 sine squared theta. All right. Guess what? What's x squared? Fletcher?
25 cosine squared?
Yeah. And what's y squared?
25 sine squared.
Cool. So x squared plus y squared is equal to 25 cosine squared plus 25 sine squared. Yeah?
Yeah.
Can I factor 25 out?
Yeah.
Okay. What's cos squared plus sine squared, Fletcher?
1.
Yeah, so this will plus 1. And so I now have x squared plus y squared equals 25. Boom. Oh, yeah, there we go. Right?
Yep. Okay.
pretty comfortable way.
Yeah, not that
But
bad.
I didn't want to do this until we did complex numbers because this is more useful to us in complex numbers. These are called parametric equations. But yeah. And so the other one, you do pretty much exactly the same.
Okay.
You square them both and then really pretty things happen and it all drops out. But I don't want you to do that.
Cool.
Okay, another question. Jasmine, Brooke?
I'm looking at that. Oh, sorry, Jasmine, you go.
Okay. Page 62,
Mm.
question 1H.
Page 62, question 1H. Okay. Page 62, question 1H. Right, so write this sum as a product. So Jasmine, what's hard about this question?
Because it says sine plus cosine.
Mm-hmm.
So
And what's wrong with sine plus cosine?
do you use the identities for products?
Yeah. Is there a sine plus cosine for sums to products or not?
Sums to product? No.
There isn't, is there?
No.
So we're going to have to try and figure out another way of looking at this. Okay.
Yeah.
So I know that cosine, something really special about cosines. And I taught this to you, trying to figure out when I taught this to you, but I taught it to you. Or maybe I taught it in school. But if I have I'm going to draw this graph, right? And this is cosine, right? Can we appreciate that's cosine?
Mm-hmm.
If this is a normal cosine curve, this is 0, this is 2 pi, pi, this is 3 pi on 2, this is pi on 2, yeah? And this is negative pi on 2, yes?
Yeah.
Now, we have this function thing. Remember how I said to you, we have a sine bx minus c plus d?
Mm-hmm.
Okay, so I want to rewrite this cosine function in terms of a sine function, right? So let's see if we can figure out what a, b, c, and d are. Okay, what's a for the cosine curve? Is it going to change?
No.
The amplitude? No, the amplitude shouldn't change. What's b? Should the frequency change?
No.
So the frequency is still the same. What is d? Should the height change, vertical shift change?
No.
No. Okay, and it's 0. And so the only thing that will change is c. And c, remember, is where the function starts. The cosine function starts at 0. Yeah? But if I were to write this as a sine function, where does the sine function start?
At the minus pi on 2.
At minus pi on 2. And so if I wrote this function, this cosine function, in terms of sine, all I'd need to do is change the the c to that. And so cosine 2 pi is the same as sine of 2x, rather. Sine of 2x minus c. And so if I write minus c correctly, it's sine of 2x plus pi on 2.
Okay.
Okay, and this is called a phase shift. And so this is something you should really, really, really get comfortable with. Sine of that is equal to cos of x, and cos of this is equal to sine of x, because they're just shifted by 90 degrees, or pi on 2. Right, so that's really, this is like a real good tidbit for you to know for later.
Okay.
Okay?
Yeah.
But for me now, you're like, okay, what do I do with this now? Well, you go, well, sine of 2x plus sine of 2x plus pi on 2, and now you can use sums to products and do it.
Okay.
Yeah, is that cool?
Yeah.
Do you need
Yeah.
me to continue, or are you happy?
No, it's okay.
Yeah, I think you can figure out your next journey point, right?
Thank you.
All good. Brooke?
Forgot. Oh wait, no. It was while we were doing Fletcher's question. I was looking at the page and realised I hadn't done 2D.
Page 55 again?
Yeah.
2D. Oh, I did this like yesterday or something. That's okay. If I wanted to be lazy, I could just find the whiteboard for it, because it's on my computer somewhere. Page 55, question 2D, yeah?
Yeah.
All right. So first off, let's write the question. Tan squared theta minus 1 over tan squared theta plus 1 equals 1 minus. Okay. So what do you think I should do? Which side?
Left side.
Okay, we'll start with the left-hand side. So it's tan squared theta minus 1. Hey, what are you talking about? We did this in our class this morning.
Oh, I may have been a little bit late to that. Sorry, sir.
It's okay. I was like, no, because yeah, we did this in class this morning. Anyway, doesn't matter. Anyway, so what interesting thing can you tell me about this? What can we do?
Tan squared plus 1 equals 6 squared.
Exactly. Tan squared plus 1 is equal to 6 squared. And can you tell me then what tan squared is equal to? Just in case.
6 squared minus 1.
Yeah. All right. And so what if I now substitute tan squared into the top? Tan squared is equal to 6 squared minus 1. Is that okay?
I guess, yeah.
6 squared minus 1. And then there's already a minus 1 at the top. And on the bottom, we write it as what?
Just 6 squared.
Yeah. And now, can I simplify the numerator for me?
I'm not sure. Wouldn't that just be 1?
It'll be 6 squared minus 2 over 6 squared. Yeah?
Yeah.
Are you sure?
Okay.
Yeah. Now what can I do? What can I do to make life a little bit easy? Oop, there we gravity.
I'm not sure. Could you?
What do you think?
I'm not sure. You can't cancel both of them out, can you?
No. But I can split the fraction like this. Can't I?
Yeah.
What can I simplify this fraction to? The first one.
1.
And so now I have 1 minus, and what's 2 divided by sec squared? What's the opposite of sec on the bottom?
Can't find it. Oh, 1 over cos.
Yeah, so it's going to be 2 cos squared. And hey, look. What's really interesting?
It's the right-hand side.
It's the right-hand side. I'm really struggling here, team. There we go. I've been trying to get that box. Does that make sense?
Yes.
Mm-hmm. All right.
Thank you very much.
You're welcome. Okay, team. So let me know if you have any more questions, but we'll try and do this again soon. But it's almost 4:30. So if you've got another question, I'm happy to answer it. But if you want to go, that's cool too. What do you want to do?
I've got another one.
Yeah, let's go. Yeah, but I think can we call it a wrap at 4:30 so that you can go relax?
Yeah.
Okay. What's up?
I was just wondering, page 44, question 3 or 4. I don't mind.
Page 44, question 3 or 4. You do not mind. Oh wow! Look at this. I'm going to do question 4. Okay, because 3 has degrees in it. I don't want to use degrees. Okay?
Okay.
Y equals... Ooh, what's going on? Y equals negative cosine x minus 1 pi over 2. Yeah? Draw this is the question, right?
Yeah.
So first off, we draw an axis. Is there a vertical shift?
No.
Okay, so we don't need to worry about that. Okay, a cosine function normally starts at 1, right? But now where are we starting? What's the negative tell you?
Negative?
Yeah, so we need to start at negative. And instead of starting at negative 1, where are we going to start at negative
3.
Okay. So I'm going to get rid of this. So we're going to call this negative 3, okay? And then it'll go all the way back up to 3. So it's a curve that will look like that. Yeah?
Yeah.
But this part here, this is C, right? C is where it starts. So where does your cosine curve start?
Sorry, I'm just catching up.
Just see
Pi 2.
pi on 2. So I'm going to call this 0. I'm going to call this pi on 2. I'm going to call this pi. I'm going to call this 3 pi on 2. I'm going to call this 2 pi. And I'm going to call this 5 pi on 2. All right? Okay. So I'm going to start a negative cosine curve at pi on 2. And then it's going to go like this, go up, and then come down. So this is going to go through here, then it's going to go through here, then it's going to go through here, then it's going to go through here. And so going backwards, it must go through here. So let me draw something that goes like this, like this, like this, like this, and like this. Hello, that is my curve.
Okay.
That looks pretty gnarly. It's because if it was on paper, I'd be able to draw a bit smoother. Or if it was an actual whiteboard, I'd be able to draw smoother. It's just on a laptop, I've got to hold my... But whatever, you can see that, right?
Yeah, sweet. Thank
You're
you.
welcome. Any questions? Jasmine, Brooke?
No.
Okay.
No.
So I might call it a day. I'm going to stop recording. I don't know how to do that though, but we'll figure that out. And then you might be asked, like, it might say, hey, give permission to this, and just do. I won't send it to anyone. I just want to see how recording works. And then if it works, then I'm going to record